This one? Yeah, works. So, good morning. I finished my talk, I think, 3 minutes ago. Looking at the timetable, so I have to hurry up. I tried to bring in the most important stuff I figured out in the last weeks and months, and hopefully nobody's kicking me off the stage talking too long. Some words to NETWAYS, what we are doing. So we have two major fields of expertise. It's open source systems management and open source data center solutions with various parts in it, like monitoring, configuration management, performance backup, and on the other side also the data center relevant stuff. And what we're doing is normal also services at customer side, like monitoring projects, managed service. We'll have monitoring hardware, and what we also do, and it's also something we have that our friends from Würth are coming over to our conferences in Germany with the monitoring and data center, taking in Nuremberg, and the next one is in October. Yeah, what we do in the community, all that stuff I'm talking about is open source. You can download it from our side. We are heavily involved in the Desinga project. I'm working there from day one. So don't be afraid, I'm not a developer. So this is a good thing for the project. I'm doing a little bit of organization there. The Desinga project is 3 years old now. I think the third birthday was last Friday or so. And I'm really happy that so many people mentioned Isinga and saw that Ciolo's statistic wasn't right because I did 3 commits yesterday evening. So we have to correct it after that. Okay, so talking about systems management is a wide field, and this is my old slide, I think. So I want to remove that slide, but I think the old one is still up there, and I thought about that slide in the morning, and I was not sure if everybody understands that kind of humor, what it is, and yeah. No, it's okay. So now you have it. Live with it. The only thing I want to mention is there are some specific areas in system management. It's a wide field, and starting talking about and thinking about and preparing your slides and doing some Googling, you get in touch with various fields of security, user, capacity, availability. In every word you have management, which some guys of you are interested in, and there is something to manage. And on the other hand, it's really technical IT processes. And I want to do, a round trip regarding different tools and their processes and how it comes together at the end. And what I do is, I want to bring the tools and the process together. And I started with capacity management. Clear to me that capacity management is not the start of all evil, but the start in my circle. What you can do for capacity management is primarily trending, gathering the data over time and get the feeling how your disk, how your CPUs, your memory is consumed and how many space you have left. Also for planning your infrastructure for costs, and also for knowing how to deal with performance issues for specific times in year or something like that. There are various tools available. We had something, Olivier mentioned it, like Cacti, Moonin, or Graphite. And going to the monitoring, like Nagios and Isinga, you have PNP for Nagios, and something I want to talk about today is Ingraph. PNP for Nagios, who's knowing PNP for Nagios, or PNP? Oh, less than I thought. So it's an RD-based graphing solution. So the advantage using the performance data out of the monitoring is that performance information is a regular result of every plugin. So normally you have a plugin standard, which you have a return code, an output state, and then you have your performance data. So normally in an Nagios or Isinga world, performance data is coming. And it would be ridiculous not using it and storing it to some database. And RD is the easiest way doing that. What's going to happen that the Nagios or Isinga process is storing all the data into an RD databases after they processed the check results. And what you can see here, for example, is a load graph over a day and over a week, where you can get a feeling what's going to happen with your capacity in the next month. Some problems with that with it RD is that RD is compressing the data from time to time, so compressing hours to days and days to weeks and so on. So you lose a little bit of quality over time. So if you're looking on an RD graph after a year, you're not able to see how was your, for example, HTTP request time last January. So you're not able to do that. And so this is a problem. Also working with the data, because you can export RD databases, but it's not an API, you can work with it. And this brings us to the point where we're starting developing a new graphing tool. Its name is InGraph, which is in is better than out, and is Inganagers graph or so. That's the basic idea. And what we do, we are storing the data not in our RD, we're storing the data in a relational database model, like MySQL. You can use Postgres or SQLite for small environments, and then everything is written there. You can aggregate the data, but you can also store everything you want to and leave the pure data. So if you want to, and if you have enough space, you can look at your data a year ago and say, what was my HTTP response time 2 years ago at 12 o'clock? So you can have it. To be honest, you need more disk, you need more machine power to store that. So in a starting point, it's your decision if you want to spend that hardware and invest in that technology. What you can see is that small bar, we named it overview. So from day one, starting graphing, we have that overview bar, and then you can select a specific time frame in that overall bar, and then it's copied on the fly to the bar above, and then reloaded with the finest detail. Giving you an impression on the other one, so you really can look like you can hoover it. So it's in JavaScript pop-up that you can hoover it, and you really can see the detailed time information. And then if I remember right, there was a question regarding dynamic thresholding or something like that. So we're coming a little bit down to the technique. Because it's a relational database model, everything is stored in a database, and on top of this, there's an XML RPC daemon, which is responsible for data delivering. What we can do here, for example, is that you can use a plugin, check-in graph, and in this example is that we monitor the load average for 1 week and give a warning if the load increases more than 10%. So doing something like a baselining. So I'm not interested in if my load is more than 5 or more than 10, but I'm interested in if my load is more than 10 or 20% higher than the same time last week. So this is something you can do with that warning and critical threshold. And this is a way where you really can implement something like a dynamic thresholding, dynamic graphs, and then at the end of the day, firing up a critical event on the monitoring console and see it and doing an alert, notification, whatever, based on graphic information. So we worked on that for 1.5 years. Now it works. You can download it for free. It's GPL. So test it if you want to. So coming to the next is availability management and some ideas behind. So sometimes a project starts with, designing the architecture, the hardware. The most important thing for managers, we need an SLA agreement. And then you say, what is your service? And then they're really hard to explain that their service, how they earn money. So sometimes it's really hard to describe what my service is. So the most important thing to really monitor a service and at the end of the day sign a contract for the service is really think about what you want to monitor, what you want to achieve, and that SMART principle is an old-fashioned one, but I like it because you need some time to think about what's really important if you're talking about an SLA. Can I really achieve that kind of 99.9999 with one server and one Tomcat, for example? So is it really achievable? Is it relevant, timely? So this is something I really love and something I think it's interesting thinking about. From the monitoring perspective, I think you have two views on configuration items in a monitoring. So you have that administrator view. So the administrator is interested if a power supply has an error, if a RAID control is degraded or something like that. That is really important for the technical stuff because they have to repair it or something else. But for the service consumer, it's not relevant because they want to say, is my SAP system still up and running, or can I contact my web service or my web shop, whatever. And I think important to measure that is to build something like a business process. And there's an ICE add-on available for Nagios and iSinger, which is the business process add-on. And what you can do, you see that in this example, for you have an Exchange server and then you have 2 nodes. And what you can say is, my Exchange service is up and running if 1 of 2 nodes are up, which gives you a totally different perspective on your monitoring environment, because the Exchange administrator have to take care about that critical server, but the service consumer, so your office stuff, whatever, is not interested if some node is offline, is just want to know their service is up and running. And on top of that, at the end of the day, you have a top-level service like mail, which you probably also can fill in as a result for reporting. So you can report that mail service, and this is something you can build your SLA on top of this if you have a correct definition. And with that add-on, you can correlate that, you can configure that in files, you can define AND and OR relationships, then you can drill down, and it's really cool to coming to the fact to decide where really your problem is, independent from the service availability. Well, this is really an interesting one. What you can also do is you can do something like a visual overview of your process. So here you can see nothing, you can see some colors, but perhaps you can mention. One other point is deployment. So deployment is also something you mostly have a problem with it every day, because you have a system base, you have different servers and environments and applications, and normally every company has different methods to come to that. Though I would say the maturity is Mallory configuration. So they configure a system once a time and they hope for the administrator don't die. The system is still up and running. The guy who installed everything never will leave the company, and that's the type of hope you solve all problems you get. Others use golden images, for example. They have a base CD which they redistribute every time a new server comes in, or have custom scripts, or they have commercial packages and products, whatever. And what you can do to solve that problem, in my example, is Puppet. Puppet is one of it. There are others on the market like Chef or CF Engine you can use for it, but more interesting, like the product itself, with the idea behind. So what you can do with a product like Puppet, or also Chef or CF Engine, that you can define your system, you can describe your system and describe how it should look like. So you have central configuration files, for example. Then you could do something like a simulation and a dry run, and then you can say, okay, if I add these configuration to my environment, what's going to happen at the end of the day? So how will my systems look like? And then you can enforce it. Then you can roll out a new package, a new Apache, or a new user to your whole environment. And the most important thing is you have a documentation, because you have to write the configuration for your environment where you describe what software is installed on which server, so it's documented. And you can have a reproducible quality of your installation base. So if you build up a new application server a couple of weeks later, then you can take the same Puppet manifest in this example, reproduce it on that server, and then you have accept the same machine. So this is something getting more important. Talking about cloud computers, I don't want to disappoint somebody, but they are still computers in the cloud. You have to configure them, you have to deal with a lot of servers, infrastructures, and then it's important to have a reproducible way to enforce your configuration. You have a graphical interface, so perhaps admins don't need it, perhaps managers need it. It's getting better from version to version, but now it gives you a really good overview what's going to happen to what node, how the state is, how many errors you get. Yeah, incident management is something, it could be it could be in conjunction with deployment management, but also with the availability management. And the idea behind that is ticketing. Perhaps a pretty easy way. In this example, we have the request tracker. We also hear Jens later on with OTRS, which is also an equal product. The most important thing is if you have some monitoring information, you have critical events, you have some messages from your customers, that you deal with it in a digital way. I want to show you later on what you can do with that data later on. In this example, it's just important that you can use the ticketing for specific areas in that ITIL and systems management area, like change management or problem management or the request fulfillment. So for example, open up a ticket, can you add a new machine for me? Then you can directly fire an event, bringing up a Puppet script, and then starting up a new machine, deploying an image, totally automatic out from a ticketing system. You can do that with about 40 lines of Perl and Ruby code, so it's pretty easy to automate your process and not doing everything automatically. There are some examples of integration, what you can do with it, like monitoring or CMDB. So for example, you can assign a CMDB item to a specific ticket that the supporter sees what server is related to or something like that. So this is just some ideas you can do with it. And at the end of the day, problem management. If you have various open source tools or also commercial tools, most of them store the information in a MySQL database or in a file or whatever. I think the most important thing, if you have various tools, and normally nobody has one tool for all processes, so you have different tools in your stack which you want to bring the information together, is thinking about how they store their data and what information you can get out of them. And most of the time in that, I still have a German word, like Stammdaten, it's data, yeah. You have specific key relations, like the host name you have in the monitoring, your host name you have in the CMDB, but in the CMDB, for example, you can relate a host to a specific customer, and from a customer you come to the specific contact. So you can create a relation from a ticket, for example, that somebody's sending you a ticket, you can getting out the contact, getting out which customer it is. With hosts are related to it, then perhaps you can enrich your ticket with that information, what servers could be related to that customers, for example. So aggregating the data together is very important. And having that in a more technical example, if you wanna report, for example, incidents after an update, you can bring various data stores and results together with a simple SQL. You join some tables like ticketing, customer data, CMDB, on updates, and then you can get some pretty information, for example. Use it in a report. This is pretty easy. I know in real life, not everything is stored in the database, but there are cool open source tools available. Bring it together like Talent Open Studio, for example, which gives you the chance to visual create an ETL, so like an extract, transform, and load. It's something coming out from the data warehouse area. So an ETL process, bringing all data in a relational database model, then generate that key relations, and then you are able to reboard it. And at the end of the day, bringing it into a reporting tool. Olivier mentioned the Isinga stuff. We are using the Jasper report. There are other open source tools on the market like Pentaho or Bird. Pentaho is more, I think they are targeting the business market and business layer. Bird is technical, and for me sometimes it's a little bit too technical, and I'm missing some business features in it. And in my personal opinion, I think Jasper is something really in the middle between too business and too technical, and it has the fastest reporting engine of them. So if you want to generate 300 sides of PDF, then yeah, Jasper does the best job. So you could bring that SQL into that. And then, for example, you can generate a report, send it to your boss every week automatically on Monday morning at 8 o'clock as a PDF, and don't fill in a manual report in in a spreadsheet or whatever. So this is really something you get. Your return of investment reporting most of the time is really quick, but you don't get reporting for free. So a lot of people think, if I buy a software, I want reports. And then they say, what do you want to report? Everything. Then give them 300 sides of PDF, they read it one at a time, they throw it away. So to have a good report, you have to think about what you want to report. Then you have to create your templates. Number one in reporting on a template is bring in your own company logo. Your boss will love it. And then think about the data. And then if you invest some time, then you really, really have a reproducible outcome. You don't have to do a manual job every week or month. And at the end of the day, in that circle, what I want to achieve is that ITIL life cycle is something coming out of the box automatically. So you don't have to go and say, I want to be ITIL compatible, and then you have to hire 20 people, a change manager, and a capacity manager, and a deployment manager. So ITIL is, from the base concept, is something you achieve automatically if you think about your processes, thinking about your tools you have and how you can bring them together. And then you can see, if you look at it, perhaps also later on, because you can't see everything in detail, that you have something like service design and service transition and operation. At the end of the day, you can solve that problems with technical tools, bring them together, and then you can really, really earn a good result with open source tools. Noah, I'm good in time. Thanks so far.
Any questions for Bernd? I see you tired.
Me? Yes.
You too? So maybe we want a coffee? Who wants a coffee? Okay. So I thought we are 30 minutes late. The coffee break is 30 minutes, so we don't take coffee, and so we resolve the problem. No? Okay,
I did my best to solve that schedule problem. You see that 22 minutes. So I did a good job.
He contributed. You get a coffee thanks to his contribution. Thank you very much.